Imagine a fleet of specialized high-altitude aircraft taking off from an equatorial runway, not to drop bombs or transport cargo, but to spray millions of tons of sulfur dioxide into the upper atmosphere. The sky slowly shifts from a deep, familiar blue to a hazy, milky white. The relentless heat of the summer sun begins to dial back, and global temperatures drop for the first time in over a century. This is not the plot of a dystopian science fiction novel, but a deeply researched, highly risky proposal sitting on the desks of the world's leading climatologists. We are standing at the precipice of Earth's most audacious scientific gamble, a field known as climate geoengineering. Defined simply, geoengineering is the deliberate, large-scale intervention in Earth's natural systems to counteract global warming. For decades, the global consensus has focused almost exclusively on mitigation, the arduous process of reducing greenhouse gas emissions. But as tipping points loom and the mercury continues its relentless climb, a growing faction of researchers argues that cutting emissions may no longer be enough, forcing humanity to consider seizing direct control of the planetary thermostat. The most prominent and polarizing of these interventions falls under the umbrella of solar radiation management. This concept aims to reflect a small fraction of incoming sunlight back into space, artificially cooling the planet. The most heavily researched method within this category is stratospheric aerosol injection. By mimicking the natural cooling effects of massive volcanic eruptions, scientists propose using high-altitude balloons or specialized jets to disperse reflective particles, such as calcium carbonate or sulfur, deep into the stratosphere. Once deployed, these microscopic mirrors would ride the high-altitude winds, creating a thin global veil. Computer models from leading institutions suggest that deflecting just 1 or 2% of incoming sunlight could offset the warming effect of 1.5 degrees Celsius. The sheer efficiency of this mechanism is staggering. For a few $1 billion a year, a fraction of the cost of transitioning the global energy grid, a single nation or even a wealthy individual could theoretically stop the rise in extreme heat. Yet the staggering power of this technology introduces a geopolitical nightmare known as the termination shock. If humanity relies on stratospheric aerosol injection to mask the warming caused by ever-increasing greenhouse gases, we become tethered to the intervention. If the fleet of aircraft were suddenly grounded by war, economic collapse, or sabotage, the artificial shield would dissipate in a matter of months. The suppressed warming would snap back with devastating velocity, causing temperatures to spike exponentially faster than ecosystems or human agriculture could ever adapt. The atmospheric veil also threatens to violently disrupt deeply established regional weather patterns. Climate models indicate that while the global average temperature might stabilize, the distribution of rainfall could shift drastically. The intervention could suppress the Asian and African summer monsoons, endangering the food and water security of billions of people. One nation's attempt to cool its borders might inadvertently trigger a catastrophic drought in a neighboring continent, transforming climate intervention into a potential weapon of mass destruction, moving away from the heavens. Another major branch of geoengineering looks to the Earth itself, focusing on carbon dioxide removal. Unlike solar deflection, which merely masks the symptoms of climate change, carbon capture seeks to address the root cause by pulling greenhouse gases directly out of the ambient air. Technologies like direct air capture rely on massive arrays of industrial fans that push air over chemical sorbents, binding the carbon so it can be extracted, compressed, and permanently sequestered deep underground. The engineering hurdles surrounding these giant mechanical trees are formidable. The concentration of carbon dioxide in the atmosphere is roughly 420 parts per million, meaning the gas is highly dilute. Extracting it is thermodynamically exhausting and requires massive amounts of energy. To make a meaningful dent in global emissions, thousands of these facilities would need to be built, powered entirely by renewable energy, lest the carbon footprint of the capture process negate the very benefits it seeks to provide. The sheer scale of infrastructure required for meaningful carbon removal rivals the size of the current global fossil fuel industry. We would need to build a reverse emissions pipeline, a colossal network dedicated entirely to burying what we have spent the last 2 centuries digging up. This monumental task has sparked fierce debate among environmental economists, who warn of a profound moral hazard. The mere promise of a future technological fix might provide heavy polluters with a convenient excuse to delay the urgent, difficult work of decarbonizing our economies today. The ghost of those early ethical debates lingers over every new pilot plant. If society believes that a giant vacuum can clean up the atmosphere tomorrow, the political will to restrict emissions today evaporates. This psychological safety net is inherently dangerous, as it bets the survival of future generations on technologies that have yet to be proven at a planetary scale. The risk is not just engineering failure, but a collective complacency that locks us into a high carbon trajectory from which there is no easy return. Beyond the skies and the industrial capture plants, scientists are also scrutinizing the oceans, Earth's largest natural carbon sink. Ocean fertilization is a biological geoengineering concept that involves dumping millions of tons of iron dust into specific marine regions. Iron is a crucial nutrient that is naturally scarce in the open ocean. By artificially supplying it, researchers aim to trigger massive blooms of phytoplankton, microscopic marine algae that absorb carbon dioxide as they grow and multiply. When these phytoplankton die, a portion of them sinks to the abyssal depths, theoretically locking the carbon away for centuries. However, the deep ocean remains one of the least understood ecosystems on the planet. Early field experiments have shown that while iron seeding does indeed create massive algal blooms, the actual amount of carbon that successfully reaches the deep ocean floor is highly uncertain. The complex marine food web often consumes the algae near the surface, releasing the gas right back into the atmosphere. Furthermore, artificially manipulating the base of the marine food chain carries severe ecological risks. Massive algal blooms can deplete the surrounding water of oxygen, creating vast dead zones where no marine life can survive. The biological cascade could alter the populations of fish, whales, and other apex predators, disrupting fisheries that millions of humans rely upon for protein. We are attempting to perform bypass surgery on the global biosphere without fully understanding the patient's anatomy. This brings us to the most intractable problem of climate intervention, the crisis of global governance. Who gets to set the thermostat of the Earth? There is currently no international treaty or governing body equipped to regulate the deployment of solar radiation management or massive ocean fertilization. The United Nations Framework Convention on Climate Change focuses on emissions, not deliberate planetary manipulation. In the absence of a binding legal framework, the door is wide open for unilateral action. Imagine a scenario where a single nation, ravaged by relentless heat waves and crop failures, decides it can no longer wait for the slow wheels of international diplomacy, acting out of desperate self-preservation. This rogue actor deploys a fleet of aerosol-injecting aircraft. The resulting climate shifts plunge a rival superpower into drought. The ensuing conflict would not be fought over land or oil, but over the fundamental right to a stable climate, sparking a new era of weather-based geopolitical warfare. Leading futurists and international law experts emphasize that the technology for atmospheric deflection is alarmingly accessible. The barrier to entry is not technological sophistication, but political will and risk tolerance. This accessibility democratizes the power to alter the globe, stripping the monopoly of climate influence away from the collective and handing it to any actor with a sufficiently large budget and a runway. The necessity for a new framework of planetary governance has never been more urgent. As the geopolitical tension simmers, localized geoengineering efforts are already being tested in the world's most vulnerable regions. In the Arctic, researchers are experimenting with ice thickening techniques by pumping seawater onto the surface of sea ice during the winter. They aim to create a thicker, more resilient layer of ice that can survive the summer melt. This micro-intervention seeks to preserve the albedo effect, the natural reflectivity of the white ice that bounces solar radiation back into space. Similar desperation is driving interventions in the Antarctic, where glaciologists are proposing the construction of massive underwater berms. These artificial barriers would be built on the seafloor to block warm ocean currents from melting the vulnerable undersides of the great ice shelves, such as the Thwaites Glacier. While localized, the failure or success of these colossal engineering projects will dictate the pace of global sea level rise, directly impacting coastal cities from Miami to Mumbai. These cryospheric interventions highlight a profound shift in the human relationship with nature. We are transitioning from accidental disruptors to intentional managers of Earth's life support systems. The sheer hubris required to build walls across the ocean floor or paint the stratosphere white is matched only by the terrifying necessity of our current climate trajectory. We are being forced to choose between the known devastation of unchecked global warming and the unknown perils of a heavily engineered planet. This transition forces us to confront a deep philosophical question regarding the definition of a natural world. If we saturate the sky with reflective aerosols and mechanically filter the air of our past mistakes, the climate is no longer a wild, untamed force. It becomes a managed artifact, a product of continuous human intervention. The weather itself becomes a piece of infrastructure, requiring constant maintenance, tuning, and political negotiation to prevent catastrophic failure. The burden of this continuous maintenance will fall squarely on the shoulders of generations yet unborn. We are not just leaving them a warmer planet. If we deploy these technologies, we are leaving them a planet on life support. They will inherit the absolute obligation to maintain the giant mechanical trees and the stratospheric fleets. A single generation's failure to uphold this technological vigil would unleash the accumulated fury of the suppressed climate system upon them. Looking even further outward, the ultimate frontier of climate intervention lies entirely off-world. Space-based solar geoengineering proposes placing massive reflective shields or swarms of microscopic mirrors at the Lagrange point between the Earth and the Sun. This orbital parasol would intercept a fraction of solar energy before it ever reached our atmosphere, sidestepping the chemical risks of injecting aerosols into the stratosphere and completely avoiding the disruption of the ozone layer. The engineering challenges of a space-based sunshade are astronomical. Launching millions of tons of material into deep space requires a radical reduction in launch costs and an unprecedented leap in orbital manufacturing. Furthermore, once deployed, these massive structures would be vulnerable to solar flares and micrometeoroid impacts, necessitating a robust autonomous repair network. Yet, despite the science fiction nature of the proposal, serious feasibility studies are currently funded by major aerospace consortiums. The orbital parasol perfectly encapsulates the dual nature of our technological trajectory. It represents both the zenith of human ingenuity and the depth of our ecological failure. We are contemplating the construction of planetary-scale megastructures to protect ourselves from the exhaust of our own industrial progress. The promises of geoengineering are the promises of a second chance, a temporary reprieve from the worst impacts of a warming world, buying us the precious time needed to fundamentally restructure our civilization. The dangers, however, are as vast as the sky itself. Climate geoengineering is an unparalleled tightrope walk over an abyss of unintended consequences. As we stand in the shadow of a rapidly altering climate, the debate is no longer about whether we should study these extreme interventions, but how we will govern them when the heat becomes unbearable. Humanity has inadvertently engineered the climate for 2 centuries. We are now facing the daunting realization that we may have to intentionally engineer it to survive.